Hello everybody, and welcome to Ask Math Anything. What we do today is what we do many days, which is that we invite anyone to ask any questions that they might have about mathematics, and I'll try to go and choose some questions that might be understandable to people who are studying algebra or geometry. If you're new here, welcome. Let's find out what we'll learn about today. What questions do we have today? I see that people already started asking some of them, so I'll also see that we have some of our questions have already appeared inside the chat. Oh, wow. Okay. So I'm looking at all of these different questions. I'm trying to find something that has something interesting. Let's do this one first. This is by Unknown Monkey. Unknown Monkey wants us to talk about something from algebra. And so here's a graph. Well, here's an equation. Y equals 3x squared, yikes, my pen is a little bit wonky today, 3x squared minus 2x plus k. And we have some information about this. We know that the graph has an x-intercept of 2. And the question is, what is k? So this seems like a nifty question. So I know that some people may have seen things like this before, not everybody. I always like to start with something that we can chat about. And when you look at something like this, it's useful to maybe think about what this looks like if we wanted to graph this thing. This happens to be a graph, and the graph is of a quadratic. If it's a quadratic, don't draw the axes first. It's a quadratic where the x squared has a positive coefficient, a positive number in front of it. And so the graph looks something like this. Okay, it's going to look something like this. Oh, we also know that it has an x-intercept of 2. So there's going to be an x-axis, I guess. And somewhere along the x-axis, it's going to, I guess at 2, it's going to cross through. Maybe this is the x-axis. And maybe that means this is at 2. I don't exactly know what this looks like. We'll find out soon. Right? And then maybe the graph looks something like this. Is that sort of straight? Yeah, maybe it looks like this. Well, how would you think of this? Well, if I happen to know that it has an x-intercept at 2, what you know is that, let's draw it in a different color, what you know is that if you plug in x equals 2, you're supposed to get 0. Oh, that's all I have to do. If I plug in x equals 2, I'm supposed to get 0 here. So let's try it. Let's plug in x equals 2. You're supposed to get 0. So when you put in 2, you get 3 times 2 squared minus 2 times 2 plus k. This tells you how you can figure out what k is. Because I'm supposed to get 0, right? And so what this is it's 3 times 4, which is 12, minus 2 times 2, which is 4, plus k. I think we now know what we should choose for k. Do you see what we should do? I'm supposed to get 0, and I hope I didn't make a mistake, right? I'm supposed to say that if I plugged in 2, then I'd get 12 minus 4, which is 8, plus k. So k had better be negative 8. In order to be 0, you need k equals minus 8. And so that's the answer I'll give for this question. I think the answer is minus 8. But a little bit of me is also a perfectionist. I'm now curious, did I draw this right? I know that one of the x-intercepts is at 2. But you see, the way that these parabolas look, if it's a y equals a quadratic, especially if the quadratic has the coefficient, the thing in front of the x squared is positive, yes, the graph might be technically wrong. That's what I want to figure out next. So now if I have it looking like this, I'm a little bit curious. I know that with k equals minus 8, that's going to give x equals 2. That'll be one of the x-intercepts. But where's the other one? How can I find out where the other x-intercept is? There's a way to do this. The way to do this is if you look at the graph that's here, So now this has to do with how you solve quadratic equations. It has to do with what is the average of the two x-intercepts, the average of the two roots. Yeah, you could try to factor it. Let me look at this. 3x squared minus 2x plus k. I'm going to write it in the next screen. 3x squared minus 2x, and the k is minus 8, okay? So now suppose I tried to factor this. And if I tried to factor it, I could actually first take out a 3. X squared minus 2/3, yeah, 2/3 x, and then minus 8/3. And you might say, well, why did we bother making such a mess? Well, the reason we bothered making such a mess is because we're able to figure out what is the average of these two roots. This 3 here in front, if you multiply a graph by 3, you just stretch it. You can imagine that if there was a height which was 4, that height would go to 4 times 3, which is 12. And if there was a height which was minus 1, it would go to 3 times minus 1, which is down here, minus 3. So you stretch it, right? People are saying finding the square method or completing the square method. That's how we can think of it. So actually, if I look at this, if I wanted to know, where are those two roots? Well, something you could actually do here is you could even factor it. The reason we could factor it is we happen to know that one of the roots is 2, right? So if I wanted to factor it, I could say it's 3 times. And if I factor it, I know that one of them is 2. That's going to work. And what I do is if I wanted to be able to factor this, the way you get the other piece is that if I want to know what becomes the coefficient of x, the way you get the coefficient of x is it was x times whatever that is, minus 2 times x. And that's going to give you this piece. In particular, I'm going to write it like this. X minus box. And something really important is that the 2 plus the box is equal to plus 2/3. Does that make sense to people? Like if I'm actually going to factor this, you're right, the box is going to be negative. But if I was going to factor it as x minus 2 times x minus something, well, the x times the x gives me the x squared. The x times the green box gives me a minus green box. Minus another 2 is supposed to be minus 2/3, right? So that's how I know that the 2 plus the normal box is equal to the plus 2/3. Okay, I would also actually know that in order for this to work, I would need that the minus 2 times minus the box is supposed to be minus 8/3. But if you look at this, how do you make this happen? Well, 2 is 6/3, right? So if 2 is 6/3, then box equals minus 4/3 should work. And indeed, minus 4/3 works. You might wonder, why did I bother to write minus and then another minus? The reason is because this lets me very easily see what the roots are. The roots are going to be when x equals 2 or when x equals minus 4/3. Those are the two ways to make this whole thing equal to 0. And you can double check. The minus 2 times the minus 4/3 is indeed minus 8/3. And in general, this is what I saw some people saying in the chat. If I just look at this, I can actually tell what the sum of my two roots is supposed to be. The sum of my two roots, once I divide out the 3, is supposed to be just 2/3. So you would know ahead of time that the sum of your roots is 2/3, and one of your roots is 2. And so the other root has to be minus 4/3. Now let's go back to the picture. That means that the picture was just wrong. This is not right. The two roots are supposed to be 2 and minus 4/3. Oh no! Now, here's what I'll do to fix it. This is minus 4/3, and this is 2. And these are the roots. And now I'll draw the y-axis. The y-axis is something like this. Oh, too close to that one. Check it out. I think this is pretty legit. So what I just drew here is I said this is actually what this piece looks like. It would still be this parabola type thing, right? That's legit. But what was not legit before was I thought that the smaller root was 2. Okay, well now the graph is somewhat satisfying, and we got the answer too. All right, let's do another question. What have you guys asked today? Let's do this problem. It's a question by Joshua Wu. Joshua Wu says it's about politics, apparently. So in the United States, there are 50 states. So in the USA, there are currently 50 states. Apparently there's a proposal to make 51 states, but that's separate. Okay? So the United States has 50 states, and also in the US, every state has 2 senators. Now, the way that the United States makes laws is that we have something called the Senate, and people, I guess, make committees. Obviously, whenever you want to make a decision, you just go and make a committee, and now they have to figure it out amongst themselves. And the question is asking, how many ways can you make a committee with 3 senators, but with a rule that you can't have 2 people from the same state on the committee? How many ways to make committee? Is that how you spell committee? I'm not really sure, but I just wrote a word with 2 M's, 2 T's, and 2 E's. I'm not sure if that's right. If I spelled it wrong, please correct me. Committee. It looks a little bit weird that it has so many T's and E's. Okay, well, hopefully I have some. My spelling is not great. But anyway, how many ways to make a committee with 3 people? Okay. Oh, it's right? Wow! Yeah, because I knew this word bookkeeper. Bookkeeper has O-O-K-K-E-E, like double, double, double. And I was like, really? Committee also does? I just learned something today. How many ways to make a committee of 3 people, senators, where no state has both senators on? Right? I mean, you don't want any state to be too powerful. So how do we do a question like this? Yes, somebody has asked, what are we doing? We are doing this. We're doing politics. Suppose that you have 50 states and every state has 2 senators. How many ways can you pick a committee of 3 senators where you're not allowed to pick both people from Wyoming? Well, I guess we get to multiply, right? So there's 100 people. And so it looks like maybe it's 100 choose 3. Not exactly. I need to subtract something. Maybe it's complementary counting. Would that be the way? Well, let me give you 2 ways to do this. Okay, let's do it in 2 ways. Okay, so one way is called complementary counting. Complementary counting is where you ask a bunch of the senators to please count for you, and then you compliment them for their good efforts. No, that's not what complementary means. Actually, spelling-wise, that complement is a compliment with an I. Complementary counting, what this means, complementary counting means that somebody does all the counting for you, and it's free. That's not the kind of complimentary you're referring to, right? Not like it's a complimentary drink or a complimentary beverage. No. And actually, I don't remember how to spell that complimentary. But anyway, so what we're really talking about here is we're talking about the complement. We take away like the ones that are bad, okay? Let's take away the ones that are bad. So what we do is we take 100 senators choose 3. That's like the number of ways to pick 3 people from the 100, okay? So this is pick. Let's just write down what it's actually called, okay? It's called 100 choose 3, okay? That's like the number of ways to pick the 3 people, minus the bad ones. How many bad ones are there? Well, how could you have a bad committee? A bad committee would be called, I got both people from Pennsylvania and someone else. Does that make sense? So how would I decide that? It would be like, remember I said a bad committee is both of the people from Pennsylvania and also somebody else. I think that's the only way you can have a bad committee. So there's 50 states, right? Times. So this is called 50 states of like both from that state. So this thing here is both from some state. And then what would I multiply by? What's a reasonable thing to multiply by? Can anyone help me out? Suppose I said I have to minus something, right? So I start with all the ways to pick 3 people and I get so excited. And I say, but some of these are not allowed. The ones that are not allowed are these 50 states, where 50 ways to say that state dominated, times what? Do I times 49? Are you sure I times 49? you got to think about it, right? So like, how many ways can I make a bad committee? 2 people from Pennsylvania and anyone else. 98. It's 98 because there's like 98 other senators, right? It's like anyone else. So again, the way I make a bad committee is 2 people from California and anyone else. Okay, so there's 98 for anyone else. So I think this is legit. I think this is the answer because I'm saying I just pick the committees of the 3 people and then I subtract some stuff. I think that seems reasonable. Let's try it. How do you figure this out? Well, you got to calculate it. So the answer is going to be 100 choose 3. The number of ways to choose 100, choose 3 things from 100 is you say 100 ways to choose the first person times 99 ways to choose the second person times 98 ways to choose the third person. And then after I'm done with that, then I have to say, well, you know, you have to care about the order. Because suppose what I did is I first chose the person from Alabama, and then from Alaska, and then from Arkansas. Well, I could have gotten that same committee by first choosing the person from Alaska, and then Arkansas, and then Alabama. Right? So, by the way, I just chose these 3 states because when I went to school, we all learned some song. It was called the 50 State Song. And it was like all the states in order. And I remember that this song starts with Alabama, Alaska, and Arkansas. Anyway, I don't know if anyone still learns that song, but it used to be a thing. So anyway, you have to divide by the number of ways that you can permute these things, right? And so I've got these 3 states. How many ways could I reorder the 3 states? That's 3 times 2 times 1. Or 6, as I saw some people say. And then I minus this, my head. Let's do that. And I minus 50 times 98. Okay. Now I claim that I want to do this in 2 different ways. Oh, yes. Somebody has asked, why is it called Arkansas? You know, I used to think it was called Arkansas because there is a Kansas. And then if you have an Arkansas, shouldn't it be Arkansas? Either that or it should be Arkansas and Kansas. But I don't know enough about history to do that one properly. And so supposedly, you know, I'll trust it. Probably has to do with the way that whatever those are named after. There's some history there. So I won't go and attack that. Let's continue with this. I want an answer. So the reason I want an answer is I claim there's another way to do the same problem. So let's see. How do I get an answer out of this? Well, I'll cancel some stuff, right? I'll go and say that the 2 cancels into the 100 to make a 50. And the 3 cancels into 99 to make a 33. Do you know why I did it this way? I did it this way so that I can do the minimal amount of calculation. Look, I'm going to subtract 50 times 98. Oh, I see there's a 50 times 98 also. Isn't that neat? So what I have is I have 33 times 50 times 98 minus, be careful of the minus a 50 times 98. So if I have 33 50 times 98s minus a 50 times 98, I get 32 50 times 98s. Okay, so the answer is nice. It's 32 times 50 times 98. Gee, an answer like that, I guess we could figure out the answer afterwards, but I think this is enough for me to show that the other technique has the same answer, because it's just a multiply. How nice. So there must be another way to do this problem where you just multiply. Here's another way to do the problem, and then we'll compare the answers. Think of it this way. We first said, let's just go and pick our committee and throw away the bad ones. There's another way, which is called, hey, every state at most gets 1 person. Why don't I start by first choosing 3 states? And then for each of these 3 states, I say, hey, do you want senator number 1 or senator number 2? Clearly, the senators for that state have names. They're called senator number 1 and senator number 2, right? But what I'm saying is, you could make this committee by saying, I pick 3 states, Wyoming, Wisconsin, and West Virginia. And now, from these 3 states, it's like, great, congratulations, you're the last is first. This is like the last 3 states in the alphabet, I think, if I remember correctly. And then you say, okay, good. I got these last 3 states, and now I'm just going to, for each of those states, you can choose one of your 2 people. Some people are saying, is it 33 or 32? The reason why I wrote 32 here is because I have 33 times 50 times 98 minus 1 of the 50 times 98s. So 33 minus 1 is 32, 50, 98. But now let's finish this up. I have the other way to do it. The other way to do it is just multiply. And just multiply works by saying, I just need to pick 3 states. Pick 3 states. And then pick 1 senator from each. This is actually easier. So all I have to do here, yes, vroom. All I have to do here is I just have to say there are 50 states, choose 3, and now for each of those 3 states, I say, do you want Senator 1 or Senator 2? 2 choices. And then the next state is like, do you want Senator 1 or Senator 2? 2 choices. And the next state is Senator 1 or Senator 2. 2 choices, okay? And if I do this, this is much easier. This is just 50 choose 3 is 50 times 49 times 48 divided by 3 times 2 times 1. Okay, and there's still a times 2 times 2 times 2. That's convenient. One of the 2's cancels. And there's a 3. I guess the 3 can cancel with the 48. Giving me a 16. Is this the same answer? Oh, this is good. Remember what the other one was. The other one was 32 times 50 times 98. I see a 50. If I want a 98, let's go and grab one of these 2's and join with that 49. And if I want a 32, grab the other 2 and join with the 16. And so this matches. This is equal to 50 times 98 times 32. Same. And so math works. It's always very satisfying when you have 2 different ways of solving a problem and they come to the same thing. So that's not bad. And so I think this is a reasonable answer to the question of how you go about building these committees. What's the next question? Let's find out. Oh, I can tell you something I was thinking about lately, because there's a proposal to make a 51st state in the US. I was thinking, how would you lay out 51 stars on a flag? Of course, you know, the way the United States flag works is that there's 1 star for every single state. And so, you know, when there were 49 states, that was very easy. 7 times 7, I think? Actually, I don't remember if that's what happened. 6 times 8 is also easy. 50, whoever came up with the United States flag's 50-star pattern is a genius. It's like somehow, if you look at the US flag, it goes between long and then slightly shorter and then long and then slightly shorter. But 51 states, that will take some creativity. You don't do that by just putting like another star in the middle or something. Okay. 3 times 17 might work, but then your flag is kind of like this. So this is a highly non-trivial problem. Okay. More questions. Oh, interesting. Mart Pajula asked, how does the vector dot product relate to the area of a parallelogram? Now that's beyond the scope of this live stream, because it's for things which are beyond algebra and geometry. But I'll say it actually is the vector cross product that has something to do with the area of the parallelogram, not the area dot product, not the vector dot product. The dot product between 2 vectors which are perpendicular, for example, is going to be very high. No, it's going to be 0. It's going to be 0. Perpendicular is 0. And unfortunately, the area there corresponds to very much not 0. But the dot product, if you have 2 vectors which are parallel, is very high. On the other hand, the parallelogram's area is 0. So somehow that particular question you asked, I'm not going to answer, but I will say it's actually the vector cross product you want to look at. Okay, more questions. Immortal Banana. what are the chances that your water will taste like bananas? Relatively low. You never should say 0%, but I'll say probably 0.00001%. Some very slight percent that maybe somebody pulls a prank on me and like drops banana into my water. Okay, more questions. Lily Ma, how can you find all the dogs and cats in America using math? Oh, you're asking me, how can you find all the dogs and cats in America using math? So, am I supposed to find all of the dogs and cats in America that know how to use math? The way I would do that is I would attempt to run a live stream that has to do with the kind of math problems that dogs and cats like to do and see how many of them tune in. And then we'll soon find out how many dogs and cats in America use math. Although I have a feeling that wasn't what you asked. I have a feeling what you asked is, how do you use math to find the number of dogs and cats in America? So if I wanted to do that, that's an estimation problem. I guess I might try to go and guess, what's the fraction of people who have pets? You know what I mean? It's like somehow, if people happen to have a pet, what's the fraction? What do you think? I mean, I'm just going to randomly guess based on the people I know. It's like, what if something like a quarter of all the households have a dog or a cat? That might be the case. If I said a quarter, ask animals anything. You're saying, yeah, a quarter, a third, something around there. I don't mind. Something like that's all about reasonable. A third's easier, by the way, because the population of the United States, we're talking about households. So if I talk about the population of the US, which is about, it's okay. Oh, I see. Let's go and adjust to people, right? So if I'm going to say there's about a third of the households which have cats or dogs, and let's suppose on average that's like giving you one dog or one cat, then, because some people have lots of them, but let's just say like a third on average gives you one, then each household, let's just do another random thing. Let's assume that each household that we're talking about has, this is tricky because there are single people with pets too, but let's pretend that the household has like 3 people. I'm being really, really basic. Wow, that's a crazy number. If I said that, then I would be basically saying that for every 3 people, there's, that's okay. So for every 3 people, there's a third of a pet. So that's like 1/9 of the people. Do you see how I'm thinking? The way I'm thinking is I'm saying, suppose that for like groups of 3 people, like 3-person households, there's a 1/3 chance that there's 1 pet. That's like for every person, there's a 1/9 of a pet. And if there are 300 million people in the United States, I'd then take 300 million divided by 9, which is close enough to 300 million divided by 10. That's like 30 million. And so I'd be getting a number which is about 30 million dogs or cats in the US. That sounds high. Does anyone know the answer? I'm actually curious what the answer is. Yes, we're assuming a ton of things here. And I'm just doing a back of the envelope, just trying to go and guess. Yes, Skylar is right. I was too lazy to take a proper 1/9. But the reason is also because my assumptions are all crazy. It's like there are also people who live alone, who, because they live alone, they also would like to have a pet. So maybe it's even higher than that. But I already got some number, which is like 30 million. Okay, so I'm way off. It turns out that the number of pets is approximately 120 million. That's impressive. Although, how far were we off? We were only off by a factor of about 4. So there's actually a lot. There's a lot of dogs and cats in the United States. I never thought about that. That's amazing. So we're saying that the US has 300 million people and like 120 million dogs or cats. So there's like, if you took the number of people in the US, it's barely more than double, or like it's 2 to 3 times the number of cats, and the dogs and cats. That's amazing. And like if you go and take into account all the different kinds of other pets people might have, like mice, like ferrets, like guinea pigs, like snakes, like turtles. Somebody has a pet tiger somewhere. Do not try that at home. But anyway, it's like all these random pets. It's like, are there more pets than people in the US? Now I'm kind of curious. Like ants. Well, if you count the ants, then I would be willing to believe that there are more pets than people in the US. But now I'm actually kind of curious. Are there actually more pets than people in the US? Based on what we calculated with the dogs and the cats, it could actually be true. Okay, I've just learned something today. That's pretty neat. I did hear, by the way, that there is a country in the world, I think it's New Zealand, where there are more sheep than people. So this is not like out of the imagination. Ah, yes, somebody has said that there are, unknown monkey has said there's 1 quadrillion ants in the world. And so yes, ants, there's a lot of ants. And if anyone likes to have pet bacteria, then those will definitely outnumber us very soon. But please do not grow pet bacteria. Please do not do that at home. Okay, more questions. Huh. Yes, I see. We've got lots and lots of different questions here. Ah, okay. One of these puzzles. Let's do a number puzzle. And this number puzzle is from Jenny. The number puzzle is 1, 2, 3 plus 2, 5, 2 equals 7, 4, 8. It doesn't, but what Jenny said is move one number. And fix it. So after we move one number, this is supposed to fix it and be a true statement. Really? All right. Challenge accepted. How do you do this? So we get to move only one number. Well, if I want to add to 748, right now it adds up to something pretty small. Like, what does it add up to right now? 3 plus 2 is 5. 2 plus 5 is 7. So it's like 57. No, I did it wrong. 75. It's 375 right now. 375, like, no, that's not good. Okay. Oh, come on. You guys are clever. Carbon News said, just put the 1 and move it onto the equal sign. So Carbon News says, just grab this 1 here and just put it right there as a not equal to. That might be the answer, but before we declare that we will surrender or play a trick, I'm a little curious if that's the best thing you can do. It looks sort of bad otherwise, because it's like, how do I fix this 700? If I want to fix this 700, I would have to put a 5 in front somehow. Putting a 5 in front, I could get 522, but then unfortunately, it's not gonna work on the last digit because the 3 plus 2 doesn't end in 8. So I don't see a nice way just to go and get the 7 legitimately. And because the sum of these numbers was already some 300 something, it's not going to match there. So I think what we're going to say is, unfortunately, I don't think we have a better idea. We just will grab the 1 and we'll put it here. And I'll ask Jenny. Jenny, if there's a better answer, please let us know. Otherwise, I think that this is in fact what people are going to do. Oh! Whoa! Daksh Gupta has a non-cheating solution. Wait a second, this is pretty clever. What? Daksh Gupta says, take the 2 and put it here. Really? Okay, let's try it. Glad you're here. 123 plus 25 squared. What's that? Well, that's equal to 123 plus 625. Ah, 3 plus 5 is 8. 2 plus 2 is 4. Oh, Daksh Gupta, you're good. It works. Amazing. Okay, so this is nice. I like this. This is far, far better than the cheating method that we were going to use before of saying just grab this 1 and put it over there. Thanks very much, Jenny, for a very clever question. We really like it. And thanks, Daksh Gupta, for solving the problem for us. More questions. I see that there are a lot of questions by Philip Neller, or maybe other people too, about Newcomb's paradox. I actually don't know what is Newcomb's paradox. I don't necessarily know all of these paradoxes and theorems by the exact name. And you're asking me, what's my opinion or side on Newcomb's paradox? If you can mention what Newcomb's paradox is, if you can say a little bit more detail, then I can share my opinion about it. Very happy to learn more. But I have seen you ask this many times, so I do want to get to it. The only reason I never answered it is because I just didn't know which paradox you're referring to. Okay. Yes, someone Google it. We can actually maybe just do it right now so it doesn't end up being something that keeps going into the chat. So, yes. So what is this Newcomb's paradox that you speak of? I'm a little bit curious. Meanwhile, I can see that various people are discussing various aspects of some of the questions that we've talked before. Oh, it's a game. So people are saying that Newcomb's paradox is a game. Maybe? So in that case, I'm wondering if this is more sophisticated, that it will take a while for us to digest. Meanwhile, let me give a quick answer. Somebody has asked, where are all of the old daily challenge, where are all of the old videos on this channel? This channel actually only leaves the videos up for like a few days because we just keep having other ones. Dr. Gupta, what was the paradox again? It was called Newcomb. Newcomb. Like a new comb. That's what this was, like a Newcomb's paradox. But I don't exactly know what this paradox is. So, when we find out what it is, then I can share you my opinion about it. Yeah, Newcomb's paradox. Oh my goodness, I see this now. So it has appeared into our chat as an enormously long thing. Okay, what do we have? Ooh, okay, here's what I'm going to say. Now that I see what it is, it's pretty long. And because it's pretty long, it's going to take me a while to actually go and think through and figure out. So unfortunately, I don't have a great answer for you right away, just because it seems like it will take me a while to go and figure out exactly what's going on here. So usually what I like to do is I like to go and talk about questions that are easy for everyone to grasp and then maybe have something interesting in them. And my general attitude with these longer things is the reason I don't want to discuss it is because it takes a while for everyone watching the live stream to absorb the context of it before they can all also understand how to solve it. So let's pass on that one. Okay, more questions. Susan Xu, do you agree that mosquitoes should be wiped of existence? Should we get rid of all the mosquitoes in the world? So I do know that some people are trying to do that. The problem is so my personal opinion is I think that's very dangerous. I think somehow nature is a very delicate balance, and things that we think are annoying, you never know if they do something that's useful. For example, who would have imagined that bacteria are useful? But there are bacteria in your intestines that do some kind of work, and they ultimately let us live because they do some kind of digestive work. You might ask, what about the mosquitoes? They seem to only do bad things to humans. That is true, but I don't know enough about the food chain and the ecosystem to know what would happen if you really got rid of all the mosquitoes. So I'm a bit scared to say just get rid of mosquitoes. Bees are a good example. Actually, if you asked me when I was younger, when I was a lot younger, I would have said, I don't know if I care too much about mosquitoes, but I really hate bees. You know what I mean? So suppose you imagine, if you were in elementary school, or maybe you still are in elementary school, what would you rather have? A swarm of mosquitoes around you or a swarm of bees around you? See, the thing is, yes, bees only sting if they feel provoked. You're right. I didn't quite know this, and I would always be kind of scared of them anyway, because, what if they just find me annoying? You know what I mean? So it's would you, if you ask a kid, what would you rather have around you, a swarm of mosquitoes or a swarm of bees? Most likely they would say the swarm of mosquitoes. But then people would be saying bees are bad, right? But actually bees are really important. Bees pollinate all the flowers. They pollinate all the crops. So it would be actually absolutely terrible if there were no bees. So it's all very hard to say, should we get rid of all of something? I think that nature is too delicate of a balance for us to go and say, you should really get rid of all of these. And therefore, my attitude is, I don't think we want to really get rid of all the mosquitoes. On the other hand, what we want to do is we want to learn how to control the diseases that come out. Okay, more questions. Ling Si Chen asked to find out whether there's a number it's an 8-digit number, and it has to be divisible by all of 1, 2, 3, 4, 5, 6, 7, and 8. And you're saying that the number is a perfect number, meaning that the sum of its factors, not including itself, adds up to itself. And you're also saying that all the digits are different. That's cool. The problem is that for me to find such a number is usually something that involves a lot of search. So when I look at a question like that, my thought process is, that's a really neat fact, that you can just find 8 digits which are all different, get something that's divisible by all the numbers 1, 2, 3, 4, 5, 6, 7, and 8, and even has this perfect property, which is about adding up its factors. But how to find it systematically is not easy. And so because it's not easy to find systematically, most likely the way you'd find it is by searching. Can you use Wolfram Alpha? I would probably just go and write my own computer program and just search it fast. But it's not really suitable for saying what can you do just with like drawing down some stuff with like with a pen. And that's also how you can see some problems in math have these systematic approaches. Some problems in math you do by brute force, with clever brute force. So maybe not a brute. You just do by force. You use the force. Yes. But you still have to be clever, and you have to be very patient while you do so. More questions. Oh, neat. Somebody has actually done the research to find out how many dogs and cats were as pets. And SJ says there were over 470 million dogs as pets. And there were 370 million cats as pets. And this was in the year 2018. So that's a lot of dogs and cats. And somebody else has asked, Min Kohi has said, what if it literally rained cats and dogs? That would be terrible. Hopefully that will never happen. That is called a tornado. That is the only way to literally rain cats and dogs. And in general, if you have a tornado which is raining cats and dogs on you, it's probably also raining TVs, dishes, refrigerators, and microwaves, which are all bad things to rain. So in general, stay away from tornadoes. Okay. Oh my gosh, you guys are so funny. You said the cats would survive. Yes, but I'm more worried about what else might be raining if it happened to be raining cats and dogs. Yes, it would be bad. Okay. Looking for more questions. I see that somebody, Daksh Gupta, you're asking me about these polynomials with integer. Oh. Now that's interesting. This might be too hard, but I'm going to try it. And what I mean by that is we might give up at some point when we find out we need more than what we can talk about here. Okay? But maybe it won't be too hard. Let's try. Okay, at first I looked at your problem and I was like, what do you mean? We've seen this problem before. You're telling me that P of 1 is equal to 5. And that P of 4 is equal to 83. And you're telling me that this is a polynomial. So there will also be a P of 3 that you're curious about. And you want to know, what is this? But what you're telling me is that this is a polynomial with, he wants to say it's a or he or she wants to say it's a polynomial with non-negative integer coefficients. Now, that's an interesting restriction, you see, because if you have a polynomial with non-negative integer coefficients, now we don't have that much freedom. So I think we can solve this. You see, because if I have non-negative integer coefficients, I can't like add stuff and then subtract it away. In particular, if I have a P of 4, I'm basically going to be, a polynomial is like something plus something times 4, plus something times 4 squared, plus something times 4 cubed. And you can't have any more than that. It's nothing times 4 to the 4th because it blew up. It's too big. I only have 83 here, right? So the way I'm thinking of this is that if I want a polynomial with non-negative integer coefficients, I already know that I don't have that many options. P of x has to be of the form something x cubed plus something x squared plus something x plus something. And that's my only way I can do it, because if I plug in 4, I can't get, well, I have to get 83. And if I had something times x to the 4th, it's like 256 already. Is that 4 to the 4th? Yeah, I think so. 256, too big, and I can't add like non-negative stuff and go get 83. So I only have these 4 possibilities. Okay, I also know that P of 1 is 5. Why is that useful? If you plug 1 in for x, that's just the sum of these 4 boxes, right? If I plug in 1, then I get box times 1. That's box. Plus box times 1. That's another box. Plus box times 1, still a box. Plus box. Of course, that's a box. So, oh, you're asking, why is it cubic? Well, it could be 0. This thing could be 0, right? I could put a 0 here. But I mean that there's nothing that goes further this way. I cannot have x to the 4th, or else I'm just too big, right? And that's why I'm confident that we will do this problem. It won't be too hard. So we have 4 boxes. The sum of the 4 boxes is 5. That's what this information tells me. And some of the boxes, I said the sum of the boxes is 5, and some of the boxes can be 0. But one sum is SUM, and the other sum is SOME. Okay, so if I'm going to do this, what happens? So from the first thing here, 5 tells me that the sum of the boxes is equal to 5. Now with that, we need to go and figure out how we could get an 83. Meanwhile, oh, you're calling them lumps. You could do that too. Meanwhile, I have just gotten a warning on one of my computers that I use to see all of you that says the battery is running low. So if you'll excuse me for a few seconds, I need to go and plug that in so that I can continue to see your comments. One moment. All right, I'm back. All right, so let's see, what can we do? I need to have these things add up to 5. Well, if I need them to add up to 5, now how do I make the 83? For the 83, I have these different powers that they have, right? When I plug in 4, the important thing is when I plug in 4, let's write the P of 4. It ran into my head. That's really annoying. Let's put it down under here then. P of 4 is going to be the first box times 4 cubed, which is 64, plus the second box times 4 squared, which is 16, plus the third box times 4 to the 1, plus the fourth box. And now we just go and look at this and we say, how could we get 83? This is almost like a base 4. Oh, that's what we're going to do. We want to convert 83 into base 4. And the reason is because I know that the sum of these is 5. Oh boy, what I've just figured out is that it is actually literally just the base 4 representation of 83. Why? Because since the sum of these boxes is 5, it's probably going to be that each of these things is actually less than 4. I bet that each of them is going to be 0, 1, 2, or 3. So let's go and try to figure out what is 83 in base 4 for fun. And also to solve this problem. So if I want to convert 83 into base 4, what's the best way to do this? Let's go and get a new screen. Remember, I might have showed you this. I did show you this on another live stream. 83 to base 4. Remember, all you have to do is you do 83 and you divide it by 4. And when you divide 83 by 4, that's obviously 20 with a remainder of 3. We did this before on other live streams. Okay, the next thing is you go and take 20 divided by 4, and you get 5, with a remainder, that looks like a very messy word, remainder, of 0. Next, you divide by 4 again, and you get 1, with a remainder of 1. Divide by 4 again. Finally, you're all done. It's 0, and there's a remainder of 1. And just like we did before, you now read it up here. You read it all the way up, and in base 4, it happens to be 1, 1, 0, 3 in base 4. Now, the way we explained this before was that we know that the last digit in base 4 is 3 because the last digit in any base is the remainder when you divide the number by that base. So that's why we divided 83 by 4 and got a remainder of 3. And you just keep going all the way down. So 1103 in base 4, and even if this one is not something you're familiar with, you can double check. 1103 in base 4 means that we're adding together some things. This is the 1's place, this is the 16's place, and this is the 64's place. And if you actually do the scratch work, and you do 64 plus 16 plus 1, wait, not plus 1, plus 3. There's 3 ones. Okay, plus 3. And the reason I did that is I happen to know that 64 plus 16 is 80. So that's going to be 83. It works! Okay, so this is the super fast way to convert any number into any other base. 1103, let's go back. Now we say it's 1103. And 1 plus 1 plus 0 plus 3 is 5, so it all works. So this is 1103, and now let's finish it. All I have to do is I just have to figure out what is P of 3. Thanks very much for this question. This was actually quite nice. The answer now is P of 3 is equal to 1 times 3 cubed, which is 27, okay, plus 1 times 3 squared, which is 9, plus 0 times 3, plus 3, which is equal to 27 plus 9 plus 3, which is 39, I hope. Addition is hard. I think it's 39. That was nice. Thanks very much for sharing this question. I at first was worried because it was like, got some polynomial and you have to go and figure out what the polynomial is. Maybe we have to use number theory. But then when I saw this and I saw, oh, it has this word non-negative integer coefficients, then I knew it's not going to be that bad because you gave me P of 4. And once you give me P of 4, I don't have much freedom because after a while, these powers of 4 are just so big that they would overwhelm the 83. All right, more questions. Wow. Okay. So there's like a bunch of like general questions here. We'll get to these after. I'm trying to see if there's one more math question that I can hit. Let's see. Oh. Can that? Oh, that looks like it'll be a proof. It takes a while. Oh, okay. A puzzle. A broken calculator puzzle. People seem to love these. Let's do this one. And this question is from Moonwatcher123. You seem to give me a lot of questions. Moonwatcher123. If 66 equals 2. Oh, the numbers are getting longer, so I'm going to give some more space. 66 equals 2. 999 equals 3. 8 equals 2. What a weird world we live in. 0 equals 1. The good thing is you're giving me lots of information, so we can hopefully find a pattern. 9696 equals 4. 8123 equals 2. 98 equals 3. And 88 equals 4. Finally, the question comes, what is 816982? Whoa. Okay. What's going on here? So something kind of interesting is that all of the answers are one-digit numbers. These questions have evolved into the next level. You're right. They sure have. And now, interestingly enough, it's somehow giving me one number that comes out. What other patterns do I see? In the numbers that come out, they're like 2, 3, 1, 1, 2, 3, 4. I've gotten all the numbers 1, 2, 3, and 4. Okay? So it looks like I'm getting kind of small answers in the end. Does it have something to do with remainders when I divide by stuff? I'm a little curious. But 0 equals 1. That's weird. is there anything else I can use? Well, 98 is 3 and 88 is 4. Okay, that's a difference of, I'm just like thinking about this. Like the difference of this is plus 10. When you go by plus 10, it goes from 4 to 3. That's weird. Why would you do that? I'm not sure. So, okay, I don't see that. I don't see how that would work there. If 0 is 1, 9696, it looks a lot like you're getting like a last digit from something, or you're taking the remainder when you divide something by 5. Those are how you get things which happen to have 1s, 2s, 3s, and 4s here. But if people say the answer is 6, then that's a little weird. Now, a lot of times with these problems, with these problems, oftentimes the answer has to do with something like the last digit when you do something. So, yeah, I see. Some people are saying, buy a new calculator. And at the same time, a bunch of people are saying the answer is 6. But I'll be honest, I don't exactly see why the answer would be 6. We need to know why, right? So let's see. If 0 gave 1 and 8 gave 2, what would you do with these numbers? It's based on the number of zeros? Oh my gosh. Oh my gosh. This is insane. Oh, you're right. Oh, you guys are so good. I'm actually very glad that I'm doing this live stream with so many intelligent people on it, because it makes it so that when I don't know how to solve the problem, you figure it out. It's totally the number of circles. There's 4 circles here. Oh, you guys are so good. So the answer here is like 1, 2, 3, 4, 5, 6. It's 6 circles. Okay. Done. Wow. Now, the funny thing is, if we were analyzing, so I'm thinking about like, how would we possibly try to figure this out if we didn't have a super genius bunch of people watching this live stream? You know, you would actually eventually possibly figure out that somehow there's a correlation between when there's 9s, you get 1. It's like somehow, as you go and think about all the different ways that you might try to solve this problem, like the 9s are contributing 1, and the 6s are contributing 1, if you thought about like adding. But I'll say this is amazing. It's amazing that you guys are so sharp. Okay, well, thank you. Thank you very much for helping to solve this problem, and thank you also for asking the question in the first place. All right, let's go and finish with a few quick things. Right, so somebody had said, I am bad at math. What's the point of listening here if I can't understand? Someone answer, please. Well, my hope is that we are answering things in ways that sometimes do dip to areas of math that are as understandable as possible. But I think the other real goal here is just to see how you can just play with math and do all kinds of different kinds of thinking. And many questions you can do in more than one way. Or you might find that there's some unusual connection between things that you thought had nothing to do with math and things in the real world. Actually, that's not what I meant. Like things in the real world and things that use math. For example, today we even discussed the number of cats and dogs. So hopefully this is giving you like a window into other things you can do as you think mathematically. And let's see, another question that I can use to finish up. Yeah, so AC says, my friends learned Python already, and I don't want to be the odd one out, so I'm learning Python on the internet by myself. I don't go to any courses, so it's kind of hard. Any advice? Well, I also learned a lot of things by myself, reading books or reading from the internet. And the thing you do is you just go and try to write some of those programs yourself. Just all you need is a way to be able to write a Python program and run it. And then just make yourself try to write programs that do things. For example, maybe you can try to write a program that uses Python to figure out the answer. I mean, that's a reasonable problem. It's like the problem is called enter any number and go and figure out how many loops it has. And that's like actually a Python program. So I'm just sharing with you that somehow the way you learn anything is you do stuff. And programming in particular is something that you can often actually do the stuff. And Tiger Lee says they're doing a Python game right now. Use your own creativity. Go and say, I want to make this. And then just make it. With that, that actually finishes our Ask Math Anything for today. Hope you guys had fun. And I'll be back again tomorrow at the same time. Have a great day.